So Google just dropped something insane. And this might be the moment quantum computers finally become useful for real stuff. They're calling it quantum echoes, and it could mark the beginning of the quantum era. Not theory, not hype. Actual, practical science. Here's the wild part. Google's new Willow chip just ran an algorithm 13,000 times faster than the world's fastest supercomputer. But speed isn't even the craziest part. This is the first time in history any quantum computer has done something verifiable that beats classical machines. So what does verifiable actually mean? It means you can run the same algorithm on any quantum computer of similar quality and get the same answer every single time. You can even check it against nature itself. Before this, most quantum experiments were basically party tricks, results we couldn't double check. This time, we can verify it, and that changes everything. Let's zoom out. The story of human discovery has always been about seeing deeper into nature, from telescopes revealing galaxies to microscopes uncovering cells. Quantum computers are the next lens, a lens that lets us peer into the hidden rules of reality itself. Until now, they've been stuck studying themselves, but today, they're finally being used to study nature. So what did Google actually do? They ran something called the quantum echoes algorithm. Think of it like quantum sonar. Just like bats use echolocation to map out caves, Google used quantum operations to map out how information spreads inside a quantum system. They took a group of qubits on the Willow chip and ran a series of operations forward in time. Then they poked one qubit, just a tiny disturbance, like a butterfly flap, and ran the same operations backward in reverse. Those two runs interfere with each other and create an echo pattern, a signal that reveals how the system behaves beneath the surface. In physics terms, they measured something called an out-of-time order correlator, or OTOS, which tracks how a disturbance ripples through a quantum system. In plain English, it's like watching chaos itself spread through reality. So why has no one done this before? Because these signals are unbelievably faint. It's like trying to hear a whisper in a stadium during a rock concert. Most quantum hardware just isn't clean enough to separate that whisper from the noise. But Willow is. Its quantum gates are so accurate it can run thousands of operations without collapsing under errors. That's like giving scientists superhuman hearing, able to isolate the faintest details in the chaos. Over the entire project, they recorded 1 trillion measurements. Yes, trillion with a T. That's more data than most quantum computers have ever collected combined. It's one of the most complex quantum experiments ever performed. So what makes Willow special? It's not just fast, it's precise. It uses superconducting integrated circuits that allow quantum gates to operate with unbelievable accuracy. Normally, adding more qubits means adding more noise and more errors. Willow broke that curse. It can scale up while keeping the system stable. If previous chips were like guitars constantly out of tune, Willow is the first one that can play an actual song. That precision is what made quantum echoes possible at all. Here's where it gets practical. You've heard of NMR spectroscopy, the same tech behind MRI machines. Scientists use it to determine the shape of molecules, because the shape of a molecule decides how it behaves. But NMR has limits. There are structures it just can't see, distances it can't measure. So Google partnered with UC Berkeley, used quantum echoes to predict the structure of 2 real molecules, one with 15 atoms and another with 28, and then checked those results in the lab. And get this, the quantum predictions match perfectly, not approximately, perfectly. Even crazier, quantum echoes revealed data that NMR couldn't see at all, information about longer distances inside molecules. That means quantum computers aren't just replacing old tools, they're extending them. This is like inventing a microscope that not only zooms in closer, it sees new colors of reality. Understanding molecular structure touches everything. In drug discovery, it determines how medicines bind to their targets, whether they cure or fail. Today, that process is mostly trial and error. Quantum computers could simulate all of that before ever synthesizing a single molecule. In material science, it's the same story. Batteries, solar panels, superconductors, catalysts. Every breakthrough starts by understanding how atoms dance together. Quantum echoes gives us a new way to watch that dance. This breakthrough truly marks a new era in scientific discovery, powered by the incredible precision of quantum technology. Now, this isn't just another quantum supremacy headline. This is a truly significant moment in the evolution of quantum computing, marking a departure from previous, more limited demonstrations. Back in 2019, Google showed a quantum computer solving a problem no classical computer could, but the task was basically an artificial stunt, designed specifically to highlight quantum capabilities without immediate practical application. It was an important proof of concept, but not yet a tool for real-world problems. It was like building a car that could go 300 miles an hour, but only on a one-lane test track, demonstrating raw speed in a highly controlled and specialized environment, rather than on an open road with diverse conditions. Quantum echoes is different. This is verifiable quantum advantage, real speed, real data, real science. It represents a crucial step forward, moving beyond theoretical demonstrations to practical, confirmable results. It means three things. First, it's faster than classical computers at something genuinely useful, tackling problems that have direct relevance to scientific and industrial challenges. This isn't just about speed, but about applying that speed to meaningful tasks. Second, the results can be verified and repeated, ensuring scientific rigor and building trust in the quantum system's output. And third, it directly enables real-world applications we actually care about, paving the way for tangible benefits across various fields. Verification is the fundamental difference between a magic trick, which relies on illusion, and a scientific instrument, which provides reproducible and explainable phenomena. It's about moving from wonder to understanding and utility. Before, if a quantum computer claimed an answer that would take 10,000 years for a supercomputer to check, how would you know it was right? The sheer computational burden made independent confirmation virtually impossible, leaving a significant gap in trust and reliability. Now, with quantum echoes, we can verify results by running them on another quantum computer to cross-reference findings, comparing them to real physical experiments to ensure consistency with natural laws, and matching them against predictions from established quantum theory to confirm theoretical accuracy. In other words, quantum computers can finally check each other's homework, fostering a new era of accountability and reliability in quantum computation. That's what makes this a trustable foundation for future breakthroughs, allowing us to build upon solid, verifiable ground. Google described it perfectly, drawing a powerful analogy to historical scientific advancements. They highlighted how new tools have consistently expanded our perception of reality. When we invented telescopes, we saw planets and galaxies that had always been there, but were previously beyond our sight. Similarly, when we invented microscopes, we saw cells and bacteria that had always been there, revealing a hidden biological world. Quantum echoes is the same kind of moment, a quantum telescope into the hidden structure of reality, allowing us to observe phenomena at an unprecedented scale. It's a tool that lets us finally see the intricate interactions between particles and molecules that were always happening around us, influencing everything from chemical reactions to material properties, but remained invisible until now. This new perspective promises to unlock profound insights. And just like the telescope and microscope sparked revolutions in astronomy and biology, fundamentally changing our understanding of the universe and life itself, this could ignite one in chemistry, materials science, and quantum physics itself, leading to unforeseen discoveries and technological advancements. So what's next for this groundbreaking technology? Google's working toward their next significant milestone, the long-lived logical qubit, which is crucial for scaling quantum computers to solve even more complex problems reliably. Right now, The Willow chip uses physical qubits, which are delicate and noisy, making them prone to errors. A logical qubit, however, uses multiple physical qubits to collectively correct its own errors, creating a much more stable and reliable computational unit. It's the essential foundation for building a fully error-corrected, general-purpose quantum computer, capable of performing complex calculations with high accuracy over extended periods, which is the ultimate goal for practical quantum computing. But here's the beautiful part. Quantum Echoes doesn't need to wait for that future of perfect logical qubits. It's already doing useful science today on real, imperfect hardware, demonstrating immediate utility even with current technological limitations. And Google says we could see real-world quantum applications within 5 years, including breakthroughs in drug discovery, the development of advanced battery materials, and the creation of more efficient fusion catalysts, all significantly accelerated by quantum simulation. These applications promise to address some of humanity's most pressing challenges. 5 years ago, quantum computers were primarily proving they could exist as a theoretical possibility. Today, they're proving they can help solve real problems. Each breakthrough builds on the last, making quantum computing faster, deeper in its insights, and more practical in its applications. So yeah, this might just be the moment quantum computing truly grew up, transitioning from a nascent field to a powerful scientific instrument. Quantum Echoes isn't just a faster algorithm, it's the first verifiable window into quantum reality, offering unprecedented access to the quantum world. And if history repeats itself, like telescopes and microscopes before it, which each ushered in new eras of scientific understanding and technological advancement, this could be the start of a whole new scientific revolution, transforming our world in ways we can only begin to imagine. So what do you think? Are we truly witnessing the dawn of useful quantum computing? A pivotal moment that will reshape our future? Or is this just another significant step on the long and complex journey there? Your perspective is valuable. Let me know your thoughts in the comments below. Because one thing's for sure, with breakthroughs like Quantum Echoes, the quantum future just got a lot closer, bringing with it immense potential and exciting possibilities for all of us.